Hi, Assalamualaikum. I'm Nadia. We are from Group 2. Our project is Fire Alarm System. These are my group mates, which were Muaz, Zabir, and Mohammad, Amirul, Iman. In the midst of finding a good problem statement to come up with a project which use an ARM Cortex M4 development board that implement the CMC's approach, a research paper on the application of digital signal processing in fire detection written by Zhang Yanglin, Lin Jing, and Wang Zhangqiu had caught our attention to further bring the methodology idea to the center of our research. By practicing the same approach of digital signal processing techniques used in their studies, we attempt to apply the filter impulse response method to our project. What makes our idea differ from the research paper is we use a different approach which we implement on an ARM Cortex M4 board instead, in which in this case we use STM32F446RE board to see the optimization of the same TSP techniques on different hardware. Finite impulse response can be simply understood as a filter that removes high-frequency signal component from the input and produce a cut-off frequency at the output signal. Let's say the input signal is a sum of two sine waves which were 1 kHz and 15 kHz. The FIR filter will eliminate the 15 kHz signal, leaving only the 1 kHz sine wave as the output. FIR filter is a combination of time domain and frequency domain. The left-hand side shows the signal in the time domain while the right-hand side is a frequency domain representation. In the time domain representation of the input signal, we can clearly see that there were two sine wave components which were 1 kHz and 15 kHz. After going through the FIR of the digital signal processing technique, we can see that the 15 kHz component has been eliminated, leaving only the 1 kHz signal. Based on the results obtained from the research carried out by Yang Ling, Xing, and Zhangqiu, for example, we have a set of input signals in which for this case are smoke signals. After applying the finite impulse response technique, we can see that the FIR filters the unprecise data collection, producing a smooth output signals. We can simply obtain the output by the multiplication of the input signals with the impulse response of the discrete system for a certain time period. This is the flowchart of our project. The system starts when the LED is on. First, the system will initialize the sensor. The DHT11 sensor will collect the data of smoke and humidity reading, and the data will analyze through CMCs. The LCD indicator will show the reading of current collected data from the temperature sensor. The system will check the temperature. If the temperature is greater than 40 degrees Celsius, it will continue to check the humidity reading. The buzzer will on when the humidity sensor decreases lower than 60% and the LED will blink to indicate that there is a fire. The methodology of this project consists of two parts, which were software design and hardware design. These are the steps for software design. First, we create a new project in STM32Cue-MX software. Choose Access to MCU selector to choose the STM32F446RE board and click Start Project. Next, we assign the pins on the board accordingly and edit the clock configuration correctly. Next, we need to give the name to the project and generate the code. We choose the STM32Cube IDE software to then write the code in the main.c file and import all the necessary CMCs library. Next, build, debug, and run the code. This is the example of our workspace in STM32Cube IDE software.
Hi, Assalamualaikum. My name is Muaz Zabir and I would like to explain briefly how we implement DSP in our code. Here is the example of how DSP implemented into the system. In order for the FIR to work, it needs to accumulate the sample size of previous input. Here is the present input and this is the past input, and it will be accumulate and being processed to the output. Let me show you the example of the coding. As you can see, this is the sample dataset that is being generated by MATLAB. This part of code is important for the process to work, and below is the code for the data being processed. Okay, let me show you our code. As you can see, we are trying to implement the FIR filter into our code. However, for our system, the input is in real time, and this input is needed to create and accumulate the sample dataset. So we need special code to accumulate the data. This is the code, and below is the code for data to be processed. However, during the development, we are facing issue for CMSIS DSP to be implemented into the main code. We are still trying debugging the issues in order to make our project successful. Okay, that's all from me. Thank you.
Hello, hi, my name is Amirul Iman. I'm going to demonstrate our fire alarm detection project. So as can see on the video here, we are using the HT11 sensor to detect temperature and humidity. Also, we have a buzzer to make alert sound when there is fire in surrounding area after reach a certain temperature value. Green LED will always turn on as there is no emergency alert, while red LED will start blinking when the sensor detected the fire. Also, we use the LCD display to show us our current temperature and humidity percentage. As you can see on the graph below, it was the value of the temperature and humidity that we captured during debugging session in the IDE software. Let me show the video how we demonstrate our project. First, we will use fire from the lighter to increase the temperature and use smoke to decrease the humidity percentage. Once the temperature hit 40 Celsius and the humidity hit 40%, the buzzer will start triggered and the red LED will start blinking. In our project, we are planning to use FIR to eliminate the noise in the signal that received from the sensor to make sure that our sensor have more sensitivity to detect temperature and humidity value. Thank you.